Welcome to the May 3rd edition of the Kubernetes SIG CLI biweekly meeting. I am Sean Sullivan, I'm your host. Let's go directly into announcements, and there are not many of them. We still, as far as I know, do not have any specific dates for the next release, the version 128 release. So let's go into the next section of our meeting, which is where we get to meet the new members. If there's anybody who is new or hasn't been here for a while and like to reintroduce yourself or introduce yourself to the rest of the SIG, this is your opportunity. And of course, this is just voluntary.
I'd like to introduce myself. Hello, everyone. My name is Leonid. I submitted a topic to discuss. It is my first time I participate in the meeting and in this SIG in general. I work at Google Cloud as a developer relation engineer and use and in the past contributed to Kubernetes a couple of times. Glad to be here and hope for a productive discussion. Thank you.
Pleasure to meet you. Is there anyone else who would like to introduce themselves? If not, we could move on to the next section, which is the KEP or subproject updates. Is there anyone who would like to give us an update on a subproject? I don't see anybody from Customize here. If not, we could get right into the main topics, which is, and our first topic has to do with the kubectl weight and the JSON path, arbitrary JSON path for it. I'm going to change what's being presented to this issue. Is it visible?
Yes.
Would you like to describe the issue?
Yes, thank you. So in the past, there were a few requests to extend wait command functionality beyond the status, and it had different forms. And eventually, the functionality that was implemented built based on JSON path weight when the command allows to define some predefined JSON path based on the standard JSON path specifications. And the weight behaves the same like with the status, but it monitors the value for this specific JSON path. And once the value match the one defined in the command, the weight is considered as successful and completes. However, it still leaves one specific use case outside, not supported. The case when the value for this JSON path can be known at the time of the command. The most popular example is IP address of the load balancer service. When users want to wait until the service receives the IP address. And right now it can be done based on events. It can be done based on the state. And the only way to do it is to wait by validating the specific JSON path, status.loadbalancer.ingress and IP. And because the IP is not known ahead of the time, can be known, the wait command cannot be used. And so people write some complex scripts like running in loop and getting the data and then like comparing if the IP is there or not. And similar situation happens in a couple of other cases. For example, if you would like to wait, you have a flow when after initialization, some controller set up additional annotation on the command, and it is conditioned on the logic of initialization and many more. So I wanted to suggest to extend the current implementation, but allowing defining a JSON path without value. So the functionality will be just if such a path has any non-empty value, the wait will kind of conclude. And I wanted first, before like submitting a change or creating a kept document or whatever, I wanted to hear your opinion if it makes sense, or maybe you know about an alternative solution to do it with, so the additional development will not be required.
So off the so what you said and what I've read, actually, it sounds very, very useful. The functionality you're describing. The issue looks like it's closed. It was closed on this particular PR. So I think we should, at the very least, if we're going to go down this path, have another. Should we have another issue or continue with this particular closed issue? And also, I think since Marley's been working with the JSON library in kubectl, she might have some insights here. Does anybody else have an opinion on this? I think this sounds really useful.
Yeah, I think this wouldn't actually even end up being like in the JSON path library. It's like we wouldn't have to make changes within the library. We could just split the thing up and say if there's nothing on the other side of the equal sign, or like probably shouldn't make it nothing. Like there's I don't know. We would have to figure out something that's meaningfully unique to base that off of for it to look up like a quote unquote any. Yeah.
Thank you, Marley. I took a liberty to look into the current implementation. So to make this change, there's no need to modify JSON path library at all. All logic can be implemented in the wait command handler, basically, with the minimal changes. It is, as I mentioned, it is basically an extension. So if it is okay, I will create a new issue. I believe that like reviving the closed issue will be confusing because it is in general a separate topic. I will reference this issue inside. And can you provide the guidelines of what should come next after the issue is opened?
So it will. I think that it will be, if we agree. I haven't heard too much pushback. We would triage accept it, and then we can organize the actual effort to develop it to whoever's going to work on it.
Okay, so I'll create an issue and I will then communicate in the issue about the next steps. Is it okay?
Okay, great. And if you assign me or CC me, then I I can make sure that it gets triage accepted so that we can move on with it.
Okay, great, thank you.
Does anybody else have any feedback?
No, I think it makes sense, especially the first part. The second part, I'd be a bit curious to see more of what you think a use case would look like. So if you, when you open up the issue, if you can just have some example commands of what you're expecting, I think that'll help.
Yeah, that'll definitely make it more concrete. Thanks, Eddie.
Yeah, I want to make sure we're because so the JSON path that we support in kube control and most of Kubernetes isn't a JSON path that most people would expect. So I want to make sure that we're not like muddying that water anymore. We don't support a lot of like the built-in helper functions that people would expect coming from a different JSON path library.
Yeah, I think that this isn't so much about the actual parsing of the path itself, and so much the value that we need to be working with, which shouldn't be too complicated to implement.
Yeah, do we allow regular expressions and wildcards for the rest of the implementations?
I don't think so.
I think that wildcards probably supported. I have to recheck the JSON path library, but regular expressions, I don't think they are supported.
Yeah, I'm not opposed to it. I think it sounds great, especially if we can get consistency across all JSON path and kube control.
You can certainly say containers of star if you're doing like a label selector. So there's
Okay, that's good. Yeah, I'll probably just follow that pattern then. Or assuming that I have time to pick it up before somebody else gets to it.
Okay, thanks.
Okay, great. So if we're agreed, we'll move on to the next issue, which I've just recently added OK to test to, let me share this particular tab. And this is with Mohammed. Would you like to describe your PR?
Yes. So we discussed this in last community meeting. I asked, I want to add announcement in the kubetrain helper. We have one callback that we call on port deleted or evicted. I also wanted to add the callbacks for when the deletion eviction started or when it's failed. So I have added it and also added the test. I would like someone to review it. If there is anything that need to be changed, I can do the changes. So kindly.
So I've also I'm sharing now the issue associated with it, the kubectl drain improvements, and so we'll want to triage accept that before we probably before we're going to spend too much time on the PR itself.
Okay.
But it does sound very like a very common issue that we see in the triages. Eddie, is there any background on our kubectl drain? We see this a lot, right?
Yeah, so we did discuss this. I think you might have been out for this one, Sean. I don't remember.
Okay.
But we did greenlight this PR.
Okay, great.
The LDR was they wanted to be able to hook into drain, and we said as long as you're okay with us potentially breaking you in the future, and yeah, because we don't give an API stability on library code. So
okay, should we add a triage accepted to the issue?
yeah, I'll do that.
Thanks. Thank you.
Okay, yeah, I've just added the okay to test on the PR, and I'll, if you, am I assigned to that? If you assign me or CC me, then I'll have a look.
Thank you.
Oh, it still says, does it still says need okay to test? Oh no, I got it. Okay. Okay, great. I think, should we be able to move on to the next issue? Do you have what you need to move forward, Mohammed?
Yes, yes. Yeah. Thank you. Thank you so much.
Okay, great. Okay, so Eddie, you're up next.
Yes. Do we have Brian? No, we don't have Brian. We discussed this. Brian did a great write-up on the pod metrics issues that we've been running into, where we're not quite sure what the data is supposed to be. We've had new issues be open that are related to this, so I wanted to discuss what the action was. I think the last we spoke was we were going to check in with API machinery to see what the intended purpose is. But we can probably punt this to next meeting and I can poke Brian about it.
Okay, great. And yeah, there's a API machinery meeting in about an hour and a half. If I'll. Okay, great. Let's move on to the next one, which is again, Eddie, which is for kubectl port forward.
Yeah, another one I was hoping that Brian would be here for. We've talked a few times about needing to rework port forward. There's tons of old issues that are brought back up. I tried to fix a bug this week. I have an open PR that I need to get back to some feedback on. But I think what we wanted to discuss was we do want to rewrite port forward and a lot of that old library code. The dependency there is on Speedy. And so I know that y'all had a plan to start switching some of the Speedy stuff to WebSockets. I think that's your next topic too. So do you just want to skip to that and we can continue the conversation?
Sure. So yeah, what I was going to talk about was just kind of a deep dive on, to give everybody some context on how some of these commands that use these bidirectional streaming protocols work. And so let me switch what I'm sharing here to this, and let me see if I can actually present. I have a few slides. Let me see if I can get these. Share. Let's see. Entire screen. So is that slide visible?
No, you're not sharing a window.
Not sharing the window. Okay. Okay, let's try share. And how about now?
Yes.
Okay, great. I just have a couple of slides. So I know for myself, since we were in the kubectl code, we don't really get to see a lot of, or at least I don't, I'll speak for myself, a lot of the what happens kind of in the back end, and some of our commands actually are reaching all the way into the container runtimes. And so what I was going to show was, since we're starting an effort to move from Speedy to WebSockets, was a couple of diagrams about what's going on for some of our kubectl commands that are using these bidirectional streaming protocols. So what is a bidirectional streaming protocol? So currently Kubernetes is using Speedy. We hope to move to WebSockets since it's better supported. And at a very high level, what Speedy and WebSockets are, they are you're able to throw arbitrary streams of data in both directions instead of your typical HTTP send a request, and then once you look at that request, you send a response. These bidirectional streaming protocols allow much better low latency for a bunch of different applications. And for us, those applications are, I put the commands here, like kubectl exec, kubectl copy, kubectl attach, or the aforementioned kubectl port forward. And so this particular diagram attempts to give a better explanation of what the different touch points are when we do a kubectl exec. Usually for most of our kubectl commands, they are just talking to the API server and the API server is responding. In this case, the API server and the kubelet are proxying these commands to the container runtime. And as you can see in the bottom, there is, for the container runtime interface, there is an ad hoc server created on the container runtime by doing a call to the container runtime interface called getExec on a particular node or on a particular container runtime. And then it proxies again using Unix sockets and actually gRPC in between the kubelet and the container runtime. So this diagram is pretty busy, but I think that it might be better. I'm just going to keep going and I'll answer some questions at the end, or attempt to answer the questions at the end, if that's okay. So if we have this connection between a client, say kubectl, and the container runtime, and we can send arbitrary data over this connection, what's being sent? And so it turns out that for 3 of the kubectl commands, there is a specific subprotocol that's being communicated over this connection that we call remote command, which unsurprisingly allows us to run a command on a container on one of the nodes. And it turns out that we multiplex the standard input, standard output, and standard error onto this one connection. And then on the other end, I tried to illustrate that actually the data that's coming in on standard input is actually connected to the standard input on that container. And the same for the standard output and the standard error. So it used to be just those 3 that were being communicated across this socket. But there's also TTY, there's terminal resize events that also get sent in. That's the next version of the protocol, or was the next version of that protocol. So basically what the high level is that one connection is able to, is good enough to multiplex all of the data necessary to send to a container and to receive from a container that's running in a particular node. And so how is it that we get this connection? Since we have a REST API for Kubernetes, well, our 1.1 request that we send is actually upgraded to this streaming protocol. And this is what this HTTP request and response look like. So for Kubernetes, and the purple here is the exec sub resource, meaning that we're doing an exec command, and the exact command is actually one of the query parameters. So the 2 most important headers are the connection upgrade and what bidirectional streaming protocol that we're going to upgrade to, and then in the reddish pink are the possible versions that we can negotiate for which which versions the Speedy server on the container understands. And that server, if it's successful, it's going to send, and you can see in the blue, it sends a 101 switching protocols with with the same header of the upgrade Speedy 3.1 and the chosen version of the protocol. So this is how we actually get a bidirectional streaming protocol from a typical HTTP 1.1 request. And as an aside, it doesn't work for HTTP 2.0, strangely enough. If you put in the upgrade header, it'll actually fail with a 400. So these have to be 1.1 requests. So this talks about why we want to transition from Speedy to WebSockets, which I'm not going to go too deeply into here, but it's basically that Speedy has been deprecated for many, many years, and WebSockets is the only bidirectional streaming protocol that's even really supported anymore. And so if you have any intermediaries like proxies or L7 load balancers or gateways, they have to speak this protocol in order for you to be able to have these kubectl commands work through those proxies. And so we're seeing a lot that obviously don't speak Speedy anymore since it's been deprecated for 8 years. And so this has been an issue for quite a while. And so we're addressing it now. Okay, so this is a diagram showing how we're going to attempt to, or how we are attempting to address the transition. And basically what we're trying to do is just do WebSockets from the client to the API server, since that solves our problem. And then we don't want to really touch all the rest of the elements or components in the system in our cluster, because that's going to really be difficult to get out, since we would have to basically change all the different container runtimes, which is where this bidirectional streaming protocol is terminated. And so instead, what we want to do is at the API server have a proxy that is going to, and we've already got a proof of concept of this. We terminate the WebSockets, and all of the data, all of these channels that are received at the WebSockets server are then thrown onto a Speedy client, which is communicating upstream the same way it was before. So we already have, if you're interested in looking at it, this particular PR is a work in process. We have the stream translator proxy working. These are examples of some of the exec commands and copy commands that are working. And so that's actually, I think I've spoken quite a bit. How about if I get some questions? So was this useful at all? So it would be good feedback for me is like, what didn't this explain, or what big questions do you have in your mind that this didn't give a 10,000 foot overview to?
This was great, Sean. Thank you for this info. I learned a ton. The question I have is so you said HTTP2 wasn't really a viable option. Could you go into that a bit more? I thought HTTP2 has like streams built in, but you said they're too speedy like.
Yeah, actually, it's not something that I have a lot of. It was actually surprising to me, and I think surprising to others. So HTTP 2.0 is actually built on top of Speedy. And so you would think that it would be very feature rich when it comes to bidirectional streaming protocols, but they don't surface that. And for some reason in the Go standard library, I actually ran into it by accidentally sending an HTTP 2.0 request while debugging this, and it gives me a 400 level error, and I thought I did something wrong, and I went into the library code, and it does not support the upgrade header at all for the Golang standard library. So I don't know why that is the case, because HTTP, like I said, HTTP 2.0 is speedy basically. And you would think that it would be very easy to access the functionality that's already there for this bidirectional streaming. And it's not. It's actually, yeah, I honestly, I don't know. And maybe there's something that I'm missing. But when I present, I'm going to actually present this and a little bit more at the API machinery meeting in an hour and a half. That was one of the questions I was going to have for that group was, you know, what's going on with HTTP 2.0 and why it's not a viable option, and basically WebSockets appear to be the only option.
Yeah, that's interesting. I know that there is a, what is it? It's the X library, the Go XNet HTTP2 library.
Yeah.
There's definitely something where the HTTP2 library in the Go standard library is not fully implemented or something. So yeah, I'm curious what you find out.
Okay, I'll share that with the rest of the group if I get more information, if and when.
Eddie, you said in the chat that port forward is execs to SOCAT on the node. But if I'm running in a multi-user Kubernetes and I don't have access to the node, port forward still works? I mean, that's not a question. It does still work. So how are those two compatible?
Yeah, so it still talks the same protocol that Sean just went through, but the node actually will just exec SOCAT. And it's actually a requirement for the kubelet to run. Like there's a startup check for kubelet that will fail if you don't have SOCAT.
I see.
And so one of the commands that we use this remote command subprotocol with is kubectl copy. And kubectl copy is not its own sub resource. It's actually, and I think maybe a lot of us have already seen this. If you do a copy, it actually just runs an exec where the command is tar. And so this is why you can't do a kubectl copy unless you have tar on your container, because it's going to try to exec this particular that particular binary on the container, and if it's not there, it just fails. So as far as port forward, as I mentioned, we mentioned this before, it's actually a completely separate protocol, right? It's not the same remote command sending standard input and then receiving standard output, standard error, and then also with the addition of the TTY resizing. So I actually haven't had the opportunity to get into that sub protocol and how that differs from, say, exec. But it is, yeah, it is, you know, the same. It is using Speedy, or we hope WebSockets in the same way. It's just not multiplexing those particular file descriptors.
This would be great, yeah. And cool, you were actually mostly talking to the API whenever it's HTTP, but for non-HTTP, we're just invoking out a kubectl, just because I didn't feel like doing that. So this should help with those kinds of clients.
Okay. Okay, well, I didn't have too much more on that. In fact, I just put that at the end of the meeting just so I could get a little practice on that particular presentation. And I was hoping that would be informative. So during this exercise, I initially had the opportunity to kind of dig into the container runtime, because that's where the Speedy and the WebSockets initially would have been terminated. And so I had some fun digging into some areas that I don't usually get to dig into. And of course, then we realized that actually trying to, if the server's on the container runtime, then we'd have to change every single container runtime, like containerd, cryo, and all of them, before we could actually get this. And so we wanted to reduce the scope of this effort to get, most of what we needed by just translating the WebSockets to Speedy at the API server. Okay. So that's all I had. And let me move back to this.
John, when you talk to API machinery about this, could you also bring up the Gorilla WebSocket thing, where that's like the
Yeah,
only,
that's a good point.
yeah, it's the only
So-
viable client, but it is no longer maintained or supported.
So so it turns out there's actually WebSocket code already littered throughout the system, and it's all the standard library WebSocket stuff. So and the proof of concept PR that we based this on, that Mikhail Mazursky created, he used the Gorilla WebSockets library. As you said, it's the best supported, or at least until a couple months ago was the best supported. And even the Go standard library WebSockets said go use the Gorilla WebSockets, and that's not the case anymore. So there is, you're right, there is a big question as to what library. And this library does the framing and has control frames, but basically we shouldn't be, we don't have any visibility as to how it's framing and sending these arbitrary length messages. It's just like it goes in one end and comes out the other, and we get to say what that data means, but how it's being transmitted, is part. It's an RFC, but there's multiple libraries which have implemented this WebSockets RFC, and it's actually not clear which one to use right now.
Does kubectl logs go through the same flow, or does it do something different?
I think it does something. That's actually a really good question that I wanted to find out myself, that I don't actually have the answer for. Does anybody else have info on that?
I think logs is just a long-lived HTTP connection.
So it's not bidirectional streaming, it's just HTTP. Okay.
That would
Yeah,
explain.
that's a great question, and I should know the answer to that, and I don't.
Yeah, but I guess logs doesn't necessarily mean bidirectional, although X on X off might help a bit. That would explain we have a cluster that's a bit unhealthy, and we're getting EOFs from kubectl logs, but not from anything that's going via the Speedy connection. So maybe that'll be hard to explain that. Very interesting. Thank you, Sean. That was very, very helpful.
Okay, good. And so there's an entire document that we tried to, and I'm going to put this in the chat, that tries to organize and centralize a lot of the context. Since this issue has been going on for 8 years, it's kind of hard to get your mind around all of it. And so I put in tons of links at the bottom for the issues and the PRs, and also some explanations and some diagrams on what this means. And so hopefully this document will be able to be the one place you need to go to know about this particular issue. So I don't want to beat this into the ground. Why don't I, if we don't have anything else, then I could give another 17 minutes back to everybody. Does that sound reasonable? Okay, it's good to see you all, and we will see you again in 2 weeks. Stop the recording.